Can you see the screen?
Yes, sir.
All right, so this is going to be the new chapter for today's class, curvature and radius of curvature. I have already shared the two required files for this chapter in your Google Classroom so that you can download it from there and follow the class. Okay. The first thing from this chapter is curvature, and then we'll study what is radius of curvature. Literally, curvature is the bending tendency of a curve. So how sharply or how quickly the curve is tending to bend is measured through the numerical term radius of curvature, as well as curvature at a given point on a given curve. From the introduction, we could see curvature is a numerical measure of bending of the curve. At a particular point on the given curve, we can sketch a tangent, right? And let this tangent line makes an angle psi with positive x-axis. Then curvature is defined as the magnitude of rate of change of the angle psi with respect to the arc length s. That means with respect to the arc length, what is the rate of change of the angle psi is defined as the curvature of the curve at that particular point. So at any point, we can calculate the curvature, right? Since at every single point there is a rate of change, so we can calculate curvature at every single point on a given curve. So the required formula for curvature is del psi by d psi by ds. An absolute value is taken. So every time the curvature is positive. And from the concept of curvature, it is easily understandable that smaller circles bends more sharply than larger circle. Thus, smaller circle has a larger curvature. Okay. So if the circumference is too small, then the curvature is more sharp. That means the bending tendency is too frequent in that kind of curves. So if you understand the curvature at a point, then the second thing is radius of curvature. This is simply the reciprocal of curvature. So radius of curvature is usually denoted by rho. Rho is the reciprocal of curvature. That means rho is equal to 1 by P. If curvature is denoted with P, then rho is equal to 1 by P. The second thing is how we can calculate the radius of curvature. So in this chapter, there are specifically two different types. One is for Cartesian curve, another one is for parametric curve. So based on the representation of the given curve, we will be using two different formulas to calculate the radius of curvature. If the given curve is represented in terms of Cartesian form or in terms of Cartesian representation, then the required formula is rho equal to 1 plus dy by dx whole square whole to the power 3 by 2 divided by absolute value of second derivative. That means absolute value of d square y by dx square. যেটা একটা শর্ট হ্যান্ড নোটেশন আছে 1 plus y1 square to the power 3 by 2 divided by modulus of y2, where y1 means dy by dx, y2 means d square y by dx square. That means the second derivative with respect to x. Well, there are two different rules based on the structure of the tangent. If the tangent is parallel to x-axis, then we should use the first formula. And if the tangent is parallel to y-axis, then we should use the second formula. Actually, for the first formula, y is a function of x, and for the second formula, x is a function of y. Okay. So based on the given structure, you should use the relevant formula. So these two are used for Cartesian curve, and the next one is used for parametric curve. If a curve is represented in terms of its parametric form, then x equal to f of t, that means x is a function of t, and y is equal to gt, then again y is a function of t, and t is the parameter for this curve. Then the radius of curvature for this parametric curve should be rho equal to x prime square plus y prime square whole to the power 3 by 2 divided by x prime y double prime minus y prime x double prime modulus. So this is the formula for parametric curve. Here prime means differentiation with respect to the parameter. If we take x prime, that means differentiation of x with respect to the parameter t. If we say x double prime, then it means second derivative of x with respect to the parameter t. And same thing is true for y prime and y double prime. Okay. So have you got the idea of radius of curvature finding?
Sir, can you explain the radius of curvature again? Like the concept?
The concept is actually, it is a terminology, right? So it is by definition, radius of curvature is treated as the reciprocal of curvature. Okay. Reciprocal means if we get curvature is 5, then radius of curvature should be 1 by 5. And the formula is derived from a detailed calculation of the main curve, which is actually provided in some other chapter. Actually, we need to go through the theorem of this chapter. We need to prove the theorem of these formulas, but for the time being, due to the scarcity of time, we are not going into the detail of the formula or the derivation of the formula. Okay, we are just adopting the formula. Actually, this formula has a proof. If I could show you the proof, then you could understand how is actually the structure of the formula is formed, or how the formula is actually working. Okay, so just for the time being, consider this formula as the true evidence of finding the radius of curvature, or we can say this is the right formula for calculating the radius of curvature, and following this rule we will solve some numerical problems. But the core thing is, if you take the curvature of a given curve, it will give you an idea how the curve is actually bending, how the curve is actually formed. If we see the curvature is too high, the value of curvature is too large, that means the curve is a curve which has more frequently bending, actually which is bending more frequently. That means the curve is having a more curved shape. Okay. If you consider y equal to x, this is a straight line, right? So it has no chance of bending. If we take y equal to x square, then it has a chance of bending, right? Since the curve is parabolic shaped, so the chance of bending is high in case of y equal to x squared. If we take y equal to x cube, it has lesser chance of bending compared to y equal to x squared. It's just like this. Okay. That means through the curvature nature, we understand how the curve is curving, how the given graph is curving. Okay.
Sir, I had a question.
Please go ahead.
Sir, is Taylor series and Maclaurin series going to be included in our final?
Is yeah, actually it is included.
Okay, sir. And sir, can we still submit the assignment you had given us before Eid vacation?
I already provided the outline of the assignment in my
No,
last.
sir. I meant, sir, when can we submit it? Actually, we only have
Okay, okay,
classes this
okay.
week.
Sorry, sorry. Now I got your point. Actually, the deadline is today, right? As per the previous announcement. Since your class time or your schedule has a change, so now it is up to 27th or 28th of March.
Okay, sir.
One thing I can do is you should prepare the hard copies, and for the time being you can submit the soft copy, that means make a PDF or scanned copy of your assignment and submit it in your Google Classroom. I will create a folder, or I will create an assignment in Google Classroom so that you can upload your respective assignments in that folder. And after the mid exam, when I visit IUT, I will collect it from your class representative. Okay.
Sir, actually, for other courses, we were only submitting hard copies. One teacher also asked us to actually courier the assignments after IoT opened.
Hard copies, actually, if you ask for a marks, if you ask for some credits or some assignment mark, then it is recommended to collect the hard copies as per the IT.
Yes, sir. I was wondering if we could only submit the hard copies. Okay, okay, sir. I think our CR will tell you about it. Okay, sir.
But for marking purpose, you can submit the soft copies for the time being. But once the IIT is reopened after the after the final exam, I can collect the hard copies for what should I say, for official purpose. Okay, we should submit all the documents once the semester is done. Do you understand what I'm saying? Since your assignment is a replacement of your quiz for some people, so I should keep the documents. I should keep all the documents which are related to marking process. For example, I should submit all your meet scripts, all your quiz scripts, as well as your assignment to the office. Is that clear?
Yes, sir.
Okay, done. And as I mentioned earlier, assignment is not mandatory for all of you. If you feel you should improve your score, then only you can submit the assignment. If you are satisfied with your quiz marks, then no need to submit the assignment. Clear?
Yes, sir.
Yes, sir.
All right. So moving to the next part, example 1. Find the radius of curvature at any point of the cycloid. This is a parametric curve. As you can see, the parameter theta is there. So we should use the formula for parametric curve. That means the second formula, rho equal to x prime square plus y prime square whole to the power 3 by 2 divided by absolute value of x prime y double prime minus y prime x double prime. So all you need to calculate the relevant values, relevant derivatives from the given curve. So x is a function of theta, since theta is the parameter for this problem. So x prime will be indicating dx by d theta, and from the curve calculate them, x prime, y prime, and similarly, sorry, x double prime, y double prime. And once the derivatives are made or derivatives are calculated, and then substitute them into the formula, into the main formula, and simplify it. So all you need to simplify them carefully, okay? And sometimes you may need to substitute the values using some trigonometric identities or some well-known formulas used in trigonometry. Okay, so I request you to simplify it in your script. সবাই একটু খাতায় এটা সিম্পলিফাই করো, জাস্ট শুধু স্ক্রিনে না থেকে সাথে সাথে একটু খাতা কলমে প্র্যাকটিস করো সিম্পলিফিকেশনটা। This chapter is too easy. ক্যালকুলেশনটা কি দেখেছো সবাই? ইজ ইট ডান?
Yes, sir.
Sir, almost.
ওকে, শেষ করো। Please let me know once it is finished.
Sir, I think we've finished.
Okay, very simple. Just you need to apply some trigonometric identities. The next example is show that the radius of curvature at any point of the curve is equal to 3 times the length of the perpendicular from the origin to the tangent. Just take a look, take a look at the steps of the calculation and then I will discuss. Okay. Here additionally, you just need to apply the formula of calculating the length of perpendicular from the origin. So আমরা straight line এ perpendicular length বের করতাম না? কিভাবে বের করতাম? For example, you are given a straight line and a particular point. And from that particular point, how do we calculate the length? মনে আছে?
স্যার ইকুয়েশনে এক্স ওয়াই কে কোঅর্ডিনেট দিয়ে রিপ্লেস করে তারপর নিচে হচ্ছে কোএফিসিয়েন্টের স্কোয়ারের সামেশনের রুট দিয়ে ভাগ দিতে হয়।
Exactly. So we'll apply the same thing. Here the particular point is origin itself. So the coordinate should be 0, 0. And we'll apply the same rule here. Okay. So just go through the steps of the problem. And once it is finished, please let me know.
Sir, I have completed the task.
Okay, so I hope most of you have completed solving the problem, and similarly you can solve some other problems like example 4, example 5. And for practice purpose, I have provided one more PDF file, which is giving you some additional examples. But the thing is, you should rely on the formula. Okay, if you know the formula, then you can use the formula to get the values. So আমরা এখান থেকেও কিছু প্রবলেম সলভ করতে পারি। This is for Cartesian equation. Okay, find the radius of curvature of the curve x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. This is a Cartesian curve, so we should use the Cartesian formula for this. সবাই একটু এই এক্সাম্পলটা দেখো। Is it done?
Yes, sir.
We have a similar one for the next curve. Do you recognize this graph? This curve x cube plus y cube equal to 3axy.
So is this called a trisectrix?
No, no, this is folium of Descartes.
Yes, sir. We did this before mode.
So we did some implicit differentiation on this curve before, right?
Yes, sir.
So the thing is, you have to use the same formula or same rule for getting the radius of curvature for this Cartesian curve. But in this case, we have to apply the implicit differentiation, and checking the implicit differentiation, we'll be able to get dy dx, and then replace the particular value of dy dx at that given point, and it is -1 at the given point. Similarly, calculate the second derivative and substitute the point, or get the second derivative value at that point. Once they are done, then use the main formula of finding radius of curvature to get the numerical value. Okay? So these are actually important problems for your final exam. Please just go through the steps. And there are a few more similar problems. Just try to go through each of them. Is it done?
Yes, sir.
There are some similar problems given in this chapter. So just try to solve each of them. It's nothing difficult. And
Sir,
similarly, for parametric curves, we have to use the parametric rule for finding the radius of curvature. And there are a few more problems on parametric curves. Okay.
sir, in this note, something called evolute was mentioned. So could you explain the concept of that?
Sorry.
Sir, in this PDF, something called evolute was mentioned. Could you please
Oh, okay,
explain?
okay. You can skip those problems because I skipped the topic. Evaluate. Okay.
Okay, sir.
Although it was included in your syllabus, but I skipped those topics. Just stick to
Sir,
the parametric curve and Cartesian curve. That's all
okay.
for this chapter.
Okay, sir. Sir, also Maclaurin series and Taylor series were not discussed in class actually. That's why I was wondering if that will actually be on the test.
Yeah, it is actually included in your syllabus. Now we are moving to that part.
Okay, sir.
It is basically chapter 9.8 from Howard Anton. Can you see the PDF?
Yes, sir.
So this Maclaurin series or Taylor series is formally known as power series. Okay, and power series is very important for differential geometry and differential calculus. That's why we should learn how to expand the power series or how to expand the Maclaurin series using the derivatives of different orders. Okay, so firstly, uh, let me remind you the formula that we used in our intermediate level, right? So we already know these rules. Have you used this formula before, or it was discarded from your short syllabus?
So we only did the examples, not the general formula, like the expansion for e to the power of
The
x.
example is actually based on these two formulas. The Taylor series is the most generalized form, and Maclaurin series is a special form of Taylor series. If you take the series about the center, that means about the point 0, then Taylor series converted to Maclaurin series. For this chapter, you must remember these two rules, must remember these two formulas. But if you know the Taylor series expansion, then you can replace the x naught by 0 to get its equivalent Taylor series. Sorry, Maclaurin series. Maclaurin series is a special case of Taylor series when the center is 0. That means when x naught is 0, then Maclaurin series is the special form of Taylor series. Okay. And in this chapter, you get to see some well-known expansion e to the power x, sine x, cosine x, 1 by 1 minus x. These are very common power series expansion. But in this chapter, we will expand the series using the binomial expansion formula. So if we move to chapter 9.7, the thing is actually discussed more briefly in chapter 9.7. Okay, so just look at example 1. If we apply Maclaurin's polynomial for this problem, we must calculate the higher order derivatives at 0 and then replace them into the formula that we studied in chapter 9.8. Alright, সবাই একটু mark করো 9.7.2. This is the required formula for generating Maclaurin polynomial for any given function f. So if your given function is e to the power x, then f will replaced by e to the power x and the remaining part will remain the same. This is the required formula for Maclaurin polynomial for any given function of degree n. So nth Maclaurin polynomial for f is represented by n degree polynomial Pnx is equal to f naught plus f prime 0 x plus f double prime 0 by 2 factorial x squared and so on. This is the general expansion formula for n degree Maclaurin polynomial. And here is an example, example 2, where we can calculate the Maclaurin polynomial for e to the power x function. আমার ধারণা এটা তোমাদের ইন্টারমিডিয়েট সিলেবাসে ছিল। Is it? সবাই একটু এক্সাম্পল 1টা দেখো, এক্সাম্পলটা সরি এক্সাম্পল 2টা দেখো।
স্যার দেখেছি।
So is it done?
Yes, sir.
Based on the same formula, we can expand it for some other functions like sine x, cosine x, also the reciprocal function 1 over 1 minus x. The rule is same, okay? And if you are dealing with Taylor polynomial, then instead of 0, you should replace any other value, x equal to x naught. That means for any non-zero value, non-zero point, you can apply Taylor series. For example, the first 4 Taylor polynomials for ln x about x equal to 2. That means you need to calculate the derivatives at the point 2, not at the 0. If you take the point 0, x equal to 0, and then calculate the derivatives at 0, then it will become a Maclaurin polynomials. Clear? So this chapter is very well known to most of you. That's why I believe that you can do it by yourself. Okay? Just go through the examples of this chapter. That would be enough. The well-known elementary functions like sine x, cosine x, 1 over 1 minus x, e to the power x, and that's enough for this chapter. Anyway, so I think that's all for this course, all for this
Sir,
semester.
is it the same for 9.8? Do we just go to the examples?
Yeah, 9.8 is actually the summary of 9.7, the same thing. So
Okay, sir.
you can apply the formulas given in 9.7. 9.8 is the additional part of 9.7, but the main core thing is discussed in 9.7. You can relate
Okay,
the problems with 9.8. Okay.
okay.
In this vacation, just go through the entire syllabus, and if you feel, we will have a how should I say, summary class or discussion class after the vacation, or review class. Okay. If you have any queries or if you have any confusion regarding any chapter, we can arrange a online review class after the Eid vacation if it is required. So thank you so much for joining, and I'm concluding my class
Excuse me, sir.
session. Yes.
Sir, it's regarding the quiz. I was marked absent on the first quiz.
Yeah, in that case, I can provide an assignment.
No, sir. Sir, I did give the quiz, but you marked me absent.
Oh, I see. Yeah, I recovered your script and you got full marks.
Thank you, sir.
I will update the mark sheet.
Thank you, sir.
Okay. So actually your script was inside another packet, another class.
So, thank you, sir.
I will update the mark sheet accordingly.
Okay, sir. Thank you, sir.
All right. So thank you very much. See you. Any other question or queries? If
No,
not,
sir.
I'm closing the session.